you can share it with everyone. So let's move on because
Okay,
we don't
sir.
have time to.
It's recording. Yeah.
We don't have too much time.
Okay.
Where is my share? Okay, so what I'm going to do here is I'm going to create two networks. So let me just start out with the some colors for them so we can keep them separated. All right, so this is going to be one network. Then there's going to be another network here. Right, so in this network on the left, I'm going to select this 2960. It's a switch that is going to connect a couple of PCs. So 1, 2, and then I'll have another switch on the other network. Okay. So this network, we will label it as network A, and we will say that this network is a class C network, class C, but a subnet, not a complete class C network. Let me zoom in so you guys can see better. Okay, and this is network B. Which is also class C subnet. All right. No, Harun, can you please try and just focus on the discussion that we're having? Okay. This is going to be for class C, but you need to understand the principle. Okay, so let's start off with this requirement. We are given a network which is 192.100.50.0, and we are given the subnet mask 255.255.255.0. Okay, and the requirement is to split the network into two equal subnets and share them in network A and network B. Okay, so that's the requirement that we've been given. So looking at the subnet mask, we can see that this is going to be 8 ones, 8 ones, 8 ones. So 8 times 3 is 24. So this is a /24 network. Okay, and to split this into two networks, if I turn it into a /25, if I turn this from /24, I go to /25. Okay, that means that I now have 25 ones. 25 ones means that I have stolen one bit from the host portion of the IP address. Okay, so the subnet mask tells me what is the network portion and what is the host portion. The network portion is the portion which has ones, and the host portion is the one that has zeros. Okay, so in the host portion, I have eight zeros. Okay, and I have 24 ones in 255.255.255.0. If I steal one bit, I get /25. So to find out the number of networks, okay, so stealing one bit will give me 2 to the power 1 networks. Right? So 2 to the power 1 is equal to 2. So that is, we will have two networks, right? So taking, I have two requirement. I have class A, network A and network B. So splitting it equally means splitting it into half. So going to a /25 is giving me two networks out of that /24. So that's my job done. So it basically means I need to break that /24 into a /25 network. All right. Now, how do we do that? So the easiest way is to look at what is the new boundary that is created. All right. So if I have, I'll draw out a /25 now. So 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then 1, which is the bit that I've stolen from the host side, and then 7 zeros. 1, 2, 3, 4, 5, 6, 7. Okay. So this is the stolen bit, which is the first bit. Now we can have two networks because only one bit is used. So if that bit is set to 0, so the network would be network 1, or sorry, subnet 1 would be 1, 1, 1, sorry, 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And I'm setting that stolen bit into 0. So 0, and then 1, 2, 3, 4, 5, 6, 7. So subnet 1 will have a network address of 192.168.50.0. Okay, and the way I'm getting this is I'm doing an AND operation with the binary version of 192.168.50.0 with this subnet mask that you're seeing. Okay, so because the last octet is 0, it tells me that for subnet 1, the network address is going to be 0. So subnet 1 network address is 0. Is this, sorry, 192.168.50.0. But what is the subnet mask for network 1? The subnet mask for network 1, sorry, subnet 1, I keep saying network, subnet 1 is based on this value we have here. So it's going to be 255.255.255.128. Okay, so this is subnet 1. Now to get subnet 2, what I'm going to do is I'm going to take this again, okay, and this time that first stolen bit, I'm going to keep that first stolen bit as 1. In the first subnet, I kept it as 0. In the next subnet, I keep it as 1. Okay, so subnet 2 will be 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I didn't count that. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Dot 1, and then 1, 2, 3, 4, 5, 6, 7. So if I was to do a logical AND with this mask and the network that was originally given to me, okay, we would see that we have 192.168.50.128. Okay, this is going to be the network address of subnet 2. So network address of subnet 2 is 192.168.50.128. Okay, and the subnet mask, for network 2 is going to be the same. Okay, so if I'm going to create a /25, okay, or in this case, I'm creating two /25 networks. both subnet 1 and subnet 2 will have the same subnet mask, right? So 255.255.255.128. Okay, so both the subnets will have the same subnet mask. Now, what I want to do next is I want to take the subnet that I have the network address, I have the subnet mask, okay, and I want to now identify these particular metrics which I'll mention here. So I know the network address, so it's 192.168.50.0, and the other one is 192.168.50.128. So for the first subnet, I want to know what is the first usable IP, the last usable IP, and the broadcast address. So first usable IP, last usable IP, and broadcast IP. So for this network, because the network address is 192.168.50.0, the first usable IP will be by incrementing that octet by 1. All right. So it will be 192.168.50.1. The last usable IP. So because the next subnet starts at 128, then the broadcast for this first subnet will be 127. All right, so let me first put the broadcast. It will be 192.168.50.127, and the last usable IP is not the broadcast. It's going to be 192.168.50.126. Okay, so these are the details that will be used for network subnet 1, right? And similarly, we can derive the first IP, last IP, and broadcast IP for subnet 2. So the network address is 192.168.50.128. So the first IP will be 192.168. I think up here I used 100, right? Anyway, just imagine this is 168. I'll update that one. 168.50. So 128 is the network. So the first usable IP will be 129. Right. Now, because this is a /24 broken into 2 networks, the last usable IP of this second subnet is going to be, for the second subnet, the last usable IP, the last IP, not usable, last IP will be 192.168.50.255. So the last usable IP will be 192.168.50.254. All right. That last IP is for broadcast. Similarly, the last IP within this subnet, because the boundary of this subnet is 127, and then the next subnet starts 128. And 128 is lost. It cannot be used as an IP address. Why? Because it is a network address. And I will demonstrate a little bit of that to you guys in this. So this is the information for subnet 2. Now let's imagine that we want to put subnet 1 here, subnet 2 here, and subnet 1 here. Okay. So I am assigning the second subnet. So subnet number, do I have the number assigned here? Subnet number 2. And this one is going to be given subnet number 1. Okay. So subnet number 1 and number 2. Now let's just go into a little bit of planning. I have to give this guy an IP address. I have to give this guy an IP address. The only usable IP addresses are the first IP all the way to the last. So from 1 to 126. Okay. And what I'm going to do is I'm going to reserve the first one for a router. Okay. For a gateway, a default gateway. And I will start with the second IP. So what I'm going to do is I'm going to give PC2 an IP address of 192.168.50.2. Okay. And I'm going to give PC3 192.168.50.4. All right. 50.1 is usable, but I'm not using it right now. Okay. And then over here on PC0, so these are the IP addresses that I can use. I'm going to keep the first IP for a gateway, all right? And I'm going to give PC0 and PC1 the other usable IP addresses. So I'm going to now see if I was to configure PC0. So on the fast Ethernet interface, I set it to static, and I put it as 192.168.50.128. Okay. Now, look at this. 128 is the network address for subnet 2. It cannot be used as an IP address, but I'm not getting an error right now. If I go and change this subnet mask to 128, can you see the error that is coming up? It is saying that invalid IP for this subnet mask entered. It is telling me that if you are going to have a subnet mask of 255.255.255.128, then inside that scheme, this IP address is a boundary IP. It is a network IP. So it is not going to allow me to configure it on PC0. Okay. So this was just to demonstrate that I actually cannot use that because it is a network address. So as I said, I'm not going to use 129 because 129, I'm going to reserve it for a router, like a gateway, because it's just good semantics. So I'm going to use not 129, I'll use 130. Okay. And I will put in that subnet mask of 128. And PC1, I'm going to give PC1 192.168.50.131. So I give this guy 130. I'm going to give PC1 131. Oops, sorry, wrong location. I need to go to fast Ethernet 0, paste it over here. Okay. Done. Now, I have made one mistake. Right, I've made one mistake and I'm doing it only for demonstration purposes. So let me connect up this PC to this switch. I'm going to connect it on 02 and I'm going to connect PC1 on 03. Okay, I'll fast forward time so the links are up, and now I'm going to do I'm going to send a ping. Okay, let's do it in simulation mode. Let's do this in simulation mode. So show all none, edit filters, ICMP, and ARP. Okay, I'll take a PDU, I'll put it on PC0 and say, hey, I want to go to PC1. So the first thing that we see is this ARP message. So the ICMP stays on hold and ARP message is created. The ARP message goes out. The switch will broadcast it to all active ports. We can see that, okay? And there will be a reply coming back from PC1, and that will go to PC0, right? So PC0 now in the ARP table has the MAC address of PC1. That is why we use ARP. Okay, now it sends the ICMP packet, as you can see there. The ICMP packet will go to PC1. It will come back, and it will show us success. Now, can you tell me what actually you saw was wrong? I'm going to ask you to raise your hand. Please do not talk. Raise your hand if you can tell me what I've just said. So Ahmed, you're asking me to repeat. Please remember this is being recorded. Rehan and Aya will have the recording. You can get it off them. Okay. So because I'm trying to get as much covered as I can in today's class. Rehan, you have your hand raised. Is it to answer the question I've asked?
No, sir. It was from before. I forgot to take it off. Sorry.
Sorry, Noman, I'm going to drop you off the chat room. I think it's a bit rude for you to keep your camera on and sleep. And I will raise this with you later on. Okay, please, if you're going to be in my class, you have some respect. All right? Sit properly. If you're going to have your camera on, you sit properly. This is very disrespectful. Who can answer this question? Why is there a positive success in this ping? Why is this ping successful? Yes, Soprano.
Mistake, sir. Sorry.
Okay, so what I want you guys to keep in mind is the deliberate mistake that I've made here. The deliberate mistake that I made was, let me go back to real time. I put this PC on a small subnet. This is a /25 network. This is a different network, okay? But I put this PC on a /24 network. I put this PC on a /24 network. So even though these two PCs are in different networks as per the subnet mask, we can still see that the ARP request and the ping, the ICMP, actually went through fine. And the reason is because what PC0 did is it said, hey, is this particular IP 132 inside my network? Okay, so PC0 says my range is between 129 and 254. So 132 is inside my range. So yes, I will send out an ARP. And PC1 simply replies to that ARP and the ping comes out and the reply goes back. But imagine, so look now what would happen if I was to put PC1, change its IP address to, let's say, 110. Okay, now 110 is not inside the range of PC0. Okay, so let's see what happens if I was to, so I'll delete this video, I'll take another one. If I was to send a packet here, so we can see it's an ICMP created and it dies immediately. So the reason why this ICMP is not even producing an ARP, is not even going out, is because PC0 says my range of devices inside my own local area network are between 129 and 254. 110 is outside my range, so it will not ping. It will drop the ping request and say, give you a failed message. Okay, so we can look at what that failed message is going to be. So if we go back to real time, click on the PC, desktop, command prompt, ping 192.168.50.110. We get request, no, I should say something else. Request timeout. All right. So the question now is, what should okay, Vimal, thanks for that. I think I need to change the share settings. Okay, so this is what I was showing. And I'll close this now. Okay, let me make a small change to this configuration. Now, PC0 says, hey, you're asking me to ping an IP address 192.168.50.110. That IP address is not actually within my own network, my own subnet. So do I have a default gateway defined? If I have a default gateway defined, I'll send the packet there. If I don't have a default gateway defined, I'll drop it. So let's see what happens if I go into PC0 and actually define a default gateway. So I go into IP configuration, and if I was to define the first IP inside the subnet as the default gateway, so 192.168.50.129. Okay, guys, as I can see you on your screens, can I please request all of you to have your camera switched on? If you don't have your camera switched on, in the next minute, I will drop you off the class. Okay, because one of the things that I also observe is that there's a lot of laughing and giggling going on. I'm not sure if you guys are even focusing on what I'm doing. I don't understand what am I supposed to do if I'm trying to present something to you guys, but you seem to be distracted with something else. Amar, Aya, Saeed, Muhammad, Bhumika, Hadi, all of you, please, Amatullah, Komal, you need to have your cameras on. If not, I will take you off the class. And I'm making one thing very clear. If anyone gets below 70 in the midterm, you will be failing this course. Okay, because I'm not seeing that level of seriousness from any of the students. Okay, so I'm defining the first IP inside this subnet as the default gateway. So let's see what is the behavior of PC0 now. So I'm in simulation mode. I have ARP and ICMP enabled, filtered, sorry. So from PC0, I'm going to send a ping to PC1, which you can see is 192.168.50.110, different network. Okay, I can see that an ARP is created. Now this ARP, if you see, was not there the first time. We did not have this ARP the first time. This ARP is coming up now. Komal, if you don't have a camera, I will remove you from the class.
Because I'm turning it on because it's from my phone, because I don't have a camera on PC. I'm just trying to connect them together.
Okay, so as I said, in the last demonstration, you saw that an ARP packet was not created. Okay, the reason the ARP was not created in the last demonstration was because PC0 did not have a default gateway even defined. When it has a default gateway defined, okay, it will now ARP for its default gateway. If it does not have a default gateway defined on the PC, if there is no default gateway defined on the PC, and the packet or the destination IP address is outside the range that this PC is sitting on, it will just drop the packet. Okay, let me say that again. If a PC tries to send a packet to a destination that is outside its range, it will drop that packet if the it will drop that packet if there is no default gateway defined. Okay, so I'm now going to take the following students off: Amar, Hadi, Saif, because your cameras are not on, and Alam as well. Okay. Suparna, you have a question. Have you put it in the chat? So please lower your hand, put your question in the chat, and then raise your hand. All right. So let's see what happens. Now we can see that, yeah, Suparna, the default gateway does matter, and that's the point that I'm trying to explain here. Okay. If a PC does not have a default gateway defined, then if a packet has a destination IP outside its own network, it will drop the packet. If the default gateway is defined, then we see a different behavior. And that's what I'm trying to show you here. The default gateway is defined. We defined that default gateway just a few minutes ago as the first IP address of the subnet that PC0 sits on, which is 129. That is the first usable IP of subnet 2. PC0 sits inside subnet 2. We gave PC0 an IP address of 130. We reserved 129 for the default gateway for a router. We don't have a router right now, but at least just the entry 192.168.50.129 changed the whole behavior of PC0. It changed the whole behavior. PC0 in the first instance dropped the packet, but now because it sees a default gateway, it doesn't drop the ICMP packet, it does something different. And that's what we're doing. It will create an ARP message. And the purpose of that ARP message is to find out what is the MAC address of my default gateway. Because I need to forward this ICMP request to my default gateway. So I need the MAC address of my default gateway. All right, so let's see what happens if I go forward. I can see that the ARP message has come to the switch. Now, what is the switch going to do with an ARP? It is going to broadcast that ARP out of every active port that is actually on this network. So if I click forward, it is going to broadcast it, but there is only one active port, and it sends it to the PC, and the PC says, hey, I am not 192.168.50.129, so the PC will drop that packet. All right, and PC0 says, okay, I'm not getting a response to the ARP, so I don't know what to do. So it will drop the ICMP packet. Can you see the green ICMP now? It's dropped. Okay, and the reason why this is dropped is because that particular IP address 110 is not inside the range. And even though a default gateway is defined, there is nobody responding on the ARP request for the default gateway. There's nobody responding on the ARP request for the default gateway. Okay, now I'm going to show you another trick just to try to maybe help enhance your understanding here. But let me just see what are the questions. Okay, so we don't have a router, okay? And the way we know we don't have a router is because PC0 sent a request to ARP and say, hey, who has the IP address for 192.168.50.129? Nobody replied. Now I'm going to change the IP address of PC1, okay? I'm going into PC1, I'm going to change the IP address to 129. Yeah, Sakshi, you have a question? You're
So
on
I
mute.
typed it in the chat.
Yeah, so I think I'm coming to your answer. Just
Yeah.
bear with me. Okay. Now I'm going to give PC1 the IP address of the default gateway On PC0 thinks his default gateway is 129. Okay, I've given that 129 to this guy. So in a way, I'm pretending as if PC1 is the router, PC1 is the default gateway. Okay, so let's see what happens now. What is the behavior? So I will take a PDU from PC0 to PC1. Okay. No, actually, I'm not going to do that. Sorry, that's not going to work. Let me reset, delete, escape, something. Okay. I'm going to go into PC0 and I'm going to go to command prompt and I'm going to try and ping 110. Now, when I try to ping 110, okay, that IP address does not sit inside subnet 2. It is outside of the range of subnet 2. So PC0 will say, hey, because the destination is outside my range, I need to go to my default gateway. My default gateway is defined as 192.168.50.129. Okay, so I need to ARP and get the MAC address for my default gateway. So he's going to do that. Let's see that. So I press enter. You can see the ICMP packet has been created. I press forward. Where is this going? It goes to switch 0 and it goes to switch 1. Okay, so I think, sorry, what happened is in the middle of this, there might have been some background ICMP ARP messages. So let me do ARP minus D. Okay, if I do ARP minus A, so there's no entries in the ARP table. Okay, PC0 does not have any entries in its ARP table. I'm going to stop any kind of messages going out. Now I'm going to do that. So look at this, PC0, oh God, no. I need the terminal. So PC0 is going to ping 192.168.110. The ARP message and the ICMP are created. Let's look at the ARP message, the dark green one. It's a message saying, who has 192.168.50.129. It's a broadcast going to all Fs. Okay. So that packet will come to the switch and get broadcasted out. So it comes to the switch will send it out of the active port, and PC1 will say, hey, I am 192.168.50.129. So I will reply. So he replies back. Okay. And we can see that the ARP is successful. Now the ping, the ICMP ping is ready to go out. Okay, please pay attention, guys. I'm not going to be repeating this again. This is most certainly going to come in your midterm exam. Okay, so the ICMP goes out. The ICMP now is, because it is for 110, PC0 does not know what to do with it. So it says, hey, I'm going to send it to my default gateway. My default gateway has just given me his MAC address, okay, which came back in that ARP reply. So he's forwarding this message to his default gateway. And you can see it's reached PC1, but PC1 is not actually a router. PC1 has received this message. Okay, let's open the message. And the message is coming in and saying that, hey, I want to go to destination 110. Okay, the MAC address is that of PC1. If I go and hover here, can I hover here? Let me close this and see. Yeah, so this is the MAC address B794. You can see that the packet has gone to B794. So the frame has reached the right destination device, but it is not the destination IP of PC1. PC1's destination IP is 129. So PC1 will say, hey, I've received this frame. I am not 129, and I don't know what to do with it. Sorry, I'm not 110, I'm 129. I don't know what to do with it, so I'm just going to drop it. But if PC1 was a router and it had a way to forward this, then it would forward that on. So in the interest of time, what I'm going to do now is actually implement a router and connect it up to this network where 110 actually sits. Okay, you can see that here, 110 sits in this range between 1 and 126. Okay, I'll just quickly scan the questions. No, Eric, the PC does not know that the default gateway is .1 or .129. As I told you, that is the first usable IP. A PC has to be configured with the default gateway. It is an absolute must that you configure. What's going on here? Okay, here, sorry. You have to go on that PC and you have to configure the default gateway as I've done here. If I don't have a default gateway, let me remove that. Okay, the whole behavior changes, everything changes. Look at this now. I go in and I say I want to ping 192.168.50.110 outside my network, not inside my subnet. Let me send the ping, and guess what? Move forward. Immediately, PC0 says, sorry, mate, I can't do anything with that because this is an IP address that is outside my subnet, and I don't have a default gateway defined. I'm going to drop this packet. Vimal, your question is very vague. If there is another PC sitting in subnet 2, then will the same process be repeated with that PC also?
So basically my question is, so for example, if there is PC, one more PC4, for example, on subnet 2, so will
On
that
this
PC,
subnet?
yeah, on the subnet 2, so will the same process, like where the ARP is being sent to that PC also, and the ICMP will also be sent, and the ICMP
Everything
being...
is the same. Absolutely. Every PC will behave the same way. If the PC is trying to go to a destination IP that is outside that subnet and it doesn't have default gateway, it will drop it. If it is trying to go to an IP that is outside that subnet and it has default gateway, it will send an ARP message to get the MAC address of the default gateway.
Okay. So, but
Every
for checking with the other PC, will there be another ARP packet generator, or will just be the first ARP packet will be getting this response from all the PCs?
Okay, so let's say I have another PC here. So I'm deleting the ARP cache of PC1 or PC0. I will also on PC1, I'll do ARP -D, delete the ARP cache. Okay, now PC4 comes in for the first time. And I'm going to go to PC4 and I'm going to give it an IP address from this subnet. So I'll give it 254. 192.168.50.254, and subnet mask has to be 128 because it's sitting inside this smaller subnet now. Okay, but as you can see, I'm not defining a default gateway. There's no default gateway defined. Okay, I will connect it up to the switch. I'll put it on 0/4 fast forward time. All right. And now I'm going to send, so I'm going to go back to PC0, and on PC0, I'm going to set up his default gateway as PC1. All right, so let's see what happens. 192.168.50.129. That is the first usable IP inside this subnet, and I'm assigning that as default gateway. Okay, there is no physical default gateway, but I'm just pretending. And I'm giving this guy the IP address of 129. Okay, so obviously, if I try to ping 110, PC0 will try to reach its default gateway. Okay, it doesn't have the IP address, the MAC address of its default gateway. Look at this, ARP-A, no entries. So ping 192.168.50.110. Packet is created. First is ARP, goes out. Now we have two active ports. We have two active ports. Goes out to both. PC4 says, no, I am not 129. Okay, but PC1 is 129. He will reply back. And it will go to PC0. So as you can see, PC4 now, if I go into the ARP table of PC4, it still does not have any entries. So if PC4 now wants to, so if I reset this simulation, if PC4 tries to ping 192.168.50.110, we will see that this ping is going to fail straight away. Okay, the reason this ping is going to fail straight away is because on PC4 I did not define an IP address for default gateway. So look at this, enter. What happened there? Oh, should have deleted that. Yeah, it's a request timeout. Can you see that? It's not getting a reply. It's dropping the packet. I wanted to show it as a simulation, but let's see if I can do that again. Yeah, straight away it's getting dropped because there is no default gateway defined. Now, if I go into PC4 and I go into its configuration and set the default gateway 192.168.50.129. Again, I'm repeating this over and over again. In fact, I'm repeating almost everything I'm saying 10 times. Okay. So if you want to make notes, make notes. If you want to watch this video 100 times later, watch it. But please be clear on what I'm trying to emphasize. What I'm trying to emphasize is the default gateway plays a very, very important role on the behavior of the PC. Now I entered the default gateway. Let's see what happens. I go back to PC4 and you can see that PC4, that thing is still ongoing. Okay, maybe it is or maybe it's not. Hold on. PC4 is actually sending an ARP and it is trying to find. Okay, wait, no, let me delete this. This looks wrong. All right, so I'm going to go back and I'm going to try to ping. So let me just check the ARP table of PC4. So it doesn't have any ARP entries, no MAC address to IP address mapping. It is going to now ping 110. And we see again, it creates an ARP message because it is now trying to get the IP address, the MAC address of its default gateway. PC1 still has 129, so PC1 will reply, as you can see. Okay, PC4 will say, okay, I have the MAC address of my default gateway. I'm going to send a ICMP, and PC1 will reject it. And the reason why PC1 is going to reject it is, although the packet has come to the correct destination MAC, B794, but the destination IP is not that of PC1. It is 110, whereby PC1 is 129. And PC1 says, hey, I've received a packet. I don't know what to do with it. I'm not a router. I'm going to drop it. Okay. So let's now reset the simulation. Let's go to PC1. I'm going to change its IP address back to 131. Okay. I'm going to set its default gateway to 192.168.50.129, which is the first IP in this subnet. This is also 129, and this is also gateway 129. Right. Now we'll bring the router in. I'll take the 2911, put that in. and this router has gig 0/0. So I'm going to connect this port from gig 0/0 to the switch on 0/1. This interface is down, so I'll go to the CLI. It's still booting up, so I'll give it a couple of minutes to boot up. Let me see. So safe, I think that statement is correct, but it is not the way we as network engineers talk. Okay, it's right to say if a PC has a default gateway set, then the PC has a path to communicate with IP addresses outside its network through that default gateway. Okay. So, okay, the router should be back up by now. No. Still booting. Wow, I've never seen a router take that long to boot.
So you can fast forward time.
Oh, that's why. Thank you. So I'll go to conf t. Okay, remember I did enable, go into conf t, and then interface gig 0/0, and then I'll do IP address. Okay, so I'm going to give it the IP address of this from this subnet. The first IP address from this subnet is 192.168.50.129, and the subnet mask is 255.255.255.128. Okay, and I have to do no shutdown. Okay, the interface comes up, fast forward, and that's it. Now, if PC0 tries to ping its gateway, okay, ping 192.168.50.129, simulation mode, enter, forward. This is ICMP going out. Why is ICMP, this is wrong, ICMP does not get broadcasted. Yeah, this is wrong. Sorry, this might be a simulation issue on packet tracer.
Professor, don't you set the default gateway in the switch as well, right?
No, the switch is just a forwarding device. The default gateway is an IP address. The switch is only looking at MAC addresses. We do not configure IP address on the switch. Okay. The only time we look at IP addresses on switches is if we are configuring the switch to have a management interface on VLAN 1, which we covered before in one of the labs. All right. But in this particular example, the switch is just playing the job of a dumb layer 2 device. It is only going to look at layer 2 addresses, which are the MAC addresses, and do packet forwarding based on that. Okay, see what happens now. This is strange.
So is it because PC1 and router have the same IP address?
No, I changed it to 131.
Okay.
Oh wait, the subnet mask.
So
is
subnet mask. Yeah.
But I don't see how that is going to change anything, really. Let me just let me go into real-time mode. Okay, so I think this is a message from Izan to reset the ARP table. I think that's a very good point because I just looked at the ARP table and PC1. So the ARP table is showing me that 129 is on MAC address B794. Okay, and B794 is actually PC0. Sorry, PC1. So inside PC0, it still has in its memory the IP address, the MAC address of this guy, although this is the one who has the IP address 129 now. So that's a good idea. Let me do ARP -D. Okay, and now maybe try the ping. Okay, it's working now. All right, so let's delete, reset, and go in the ping. We can see that, okay, the ICMP is coming out and it goes to the router replies. Okay, so what happens now if I try to ping 110, right? In simulation mode again, ping 110. Again, this is going to be sent to the router because it's outside the network of, outside of subnet 2. So we can see it's gone to the router. Okay, but the router has dropped the packet. So you can see the packet is going to the router, which is 5701. Okay, 5701 is the interface of gig 0/0. Is the MAC address of gig 0/0, 5701. And the destination IP is coming up as 50.110. Okay, but router 0 says, hey, I don't know what to do with 50.110. Okay, so if I look inside router 0 and I say show IP route, show me routing table, it shows me that it has connectivity to the 192.168.50.0/25 network. Can you see that? It has access to that network, and 110 does not sit inside that network, so it will drop the packet. Now let's connect it up to this side. So I'm going to reset this simulation. I'm going to go into router 0, and I'm going to go into conft interface gig 0/1, which is going to be this interface here. And I'm going to put IP address 192.168.50. I'm going to give this gateway, this router is going to act as a gateway for this network. So I'm going to give this IP address as the first IP inside subnet 1, which is 50.1. Okay, 50.1. And the subnet mask, because this is a smaller /25 network, the subnet mask has to be 255.255.255.128. Okay, and I will do no shutdown. Okay, now obviously there's nothing connected. Let me connect it up. So gig 0/1 to the switch 0/1, and I'm also going to connect 0/2 to PC2, and I'm going to connect 0/3 to PC3. Okay. Now remember, on this side of the network, I have not done any kind of configuration at all. I have not configured any IP addresses. Nothing is configured. So really, there is nobody here that has 110. Okay, let's look at the routing table now of router 0. So show IP route. Okay, now you can see that the routing table of PC0, of router 0 has been updated. Okay, the routing table before only showed me one network, 192.168.50.128. all right, and the other one is 192.168.50.0. So the two networks, these two networks, all right. I want you guys to please see this clearly. We did this mathematically. We came up with, by making this a /25, by giving 192.168.50.0 with 255.255.255.128. That is one subnet, okay? And that is exactly the configuration that I've done on router 0. I've given gig 0/0 192.168.50.1 as an IP and this subnet mask. So it says, hey, I'm connected on gig 0/0, 0/1. You see that? I'm connected to a network, which is a 50.0 network, and it is a /25 network. And it says on gig 0/0, which is this side here, I'm connected to a network which is 192.168.50.128, and it is also a /25 network. Okay. Now let's see what happens. So again, we're in our simulation mode. PC0 will now again ping 110. So the ICMP now, remember there's no ARPing required because PC0 already now has the MAC address of its router. So it will send the ICMP directly to its router. Okay. The router now, can you see, has created an ARP message. What does that tell us? Sakshi, you have your hand raised.
Yeah, so my question was in the chat.
Let me have a look. Now, if so, PC1 is connected to a router and PC0's default gateway is PC1, but PC1 does not function as a router. So if PC1 receives a packet in which the destination IP is not of PC1, it will drop the packet because it is not a router.
Oh, no, so what I meant was like PC0's default gateway is PC1, whereas PC1 is also connected to a router. And in PC1, the default gateway is set to that router's IP address.
Yes, but that's
So-
what I'm trying to tell you. PC1 is not a router. PC1 is not a router. It is a host machine. Okay, you saw what happened before. The router received the packet, okay, and because it did not have connectivity to this network, it dropped it. But now that the router received a packet and it has connectivity to this network, it is actually trying to ARP for 110. The router is a function that does that. A PC does not do that. So if you try to create this daisy chain that you're saying, where the default gateway for this guy is this guy, and this guy's default gateway is the router, so will it daisy chain and go through? No, it will not, because this guy is not a router. He doesn't have the software for routing. The software for routing is not on this host machine. It's only on this host machine. Okay, so I hope that clarifies. You can lower your hand. Okay, the reason now why this ICMP is dropped is because if we go there, it's a timeout. The router is trying to ARP and it's not getting a response. I think it's because I've had the simulation. So let me just reset that and try again. Okay, so it goes to the PC router. Now you can see the router immediately creates an ARP message. Okay, and the router says, hey, who has the IP address for 110? Sorry, who has the MAC address for 110? So this ARP now will come out of this side of the router's body, or this interface, and it will go to the switch. The switch is just a layer 2 forwarding device. It will see that I have received a packet with a destination MAC of all Fs, so I'm going to send it out of all active ports. It does that. and it gets no reply because PC2 does not own 110. PC2 actually does not have an IP even configured. So it will just drop that ARP request and say, hey, I don't even have an IP, forget about 110, right? And PC0 will try again. And again, this guy is going to ARP. And again, it will fail. And then PC0 will try again. And again. How many times will it try? That's it. It stops. I press forward, nothing happens. Because the Windows operating system that PC0 is running only sends the ping 4 times. Only 4 times. And you're getting request timeout. So to complete the story, let me go in now. I'm going to give this guy the IP address 110. Finally. Okay, let's dissect what happens now. Please, either you have your camera on or I drop you off. Okay, we can see that the ICMP request has been generated. Let's just dissect it quickly. The ICMP message is going to go to the default gateway. Okay, 5701 is the MAC address of interface gig 0/0. The source IP is 130, which is PC0. The destination IP is 110, which is where I'm trying to ping. Okay. That packet is going to now come to the router. The router is receiving this request for the first time, so it sends out an ARP request. And lo and behold, this guy doesn't reply, but he is 110, so he replies back. Okay, the router gets that message. Okay, but that ping has timed out. That ping timed out. So PC0 is going to create a new ping. New ICMP. Router 0 receives it. Now router 0 does not send an ARP because router 0 knows the MAC address of 110. So he sends it to 110. PC2 receives it and PC2 drops the packet. Oh, good. Kristen, you're smiling. Why does PC2 drop the packet?
I have no idea. I just wouldn't want.
Okay. The reason why PC2 drops the packet is because PC2 now, guys, think about this. PC2 now has to reply to a destination IP, which is 130. Who sent the request to PC2? This guy. What is his IP address? 130. Is 130 sitting inside the range of subnet 1? No. Does PC2 have a default gateway defined? No. So now PC2 has to reply to a destination that is outside its network. It does not have a default gateway defined, so it will drop the packet. Nafis, are you sleeping?
I'm here.
Well, you seem like you're sleeping.
No, I was writing down notes.
Okay. Now let's change that problem. So for PC2, I'm going to give it a default gateway of 50.1. Which hopefully tell you guys how important it is to have a default gateway. All right, let's go forward. So this is the third ICMP packet coming out. 2 have failed. Go straight to PC2. Now PC2 is not dropping the packet. PC2 is replying. It's going to go to the router, and the router will forward it back to subnet 2. And from subnet 2, it will go to PC0. And PC0 will say, hey, I got 1 reply. 3 of them failed, right? But somebody went in and made some corrections and I got a reply. The first one failed because nobody had 110. The second one failed because PC2 did not have a default gateway, even after I made it 110. The third one, I don't know how it slipped past the net, but the fourth one made it.
Sir, could I ask a doubt?
Yeah, 1 second. Yes. Did you type
Sir,
it?
could you please close the command prompt? All right, sir. Now, what if switch 1 was connected to switch 0 and also the router was also connected to switch 0? So if PC0 wanted to chat with PC2, will it send an ARP to the router or will it go directly through the switch to the second network?
Let me make it simple. If the destination IP is outside the network range of PC0, then it will ARP the gateway, which is the router. If the router gateway is configured on PC0, otherwise it will drop the packet. It will never try to go through a switch to another IP address if that IP address is outside its network and it doesn't have a default gateway defined.
Okay, sir.
All right, I've tried to demonstrate this literally step by step in as much detail as possible. Okay, and I will repeat it one more time.
Professor, but before that, I have a question.
Don't interrupt me. Let me finish what I'm saying. Please put your question in the chat. While I'm talking, don't interrupt me. All right. I'm saying this again. If a PC is trying to reach an IP address that is outside its own subnet, it will not send that request if a default gateway is not defined. Okay, it will immediately drop that ICMP request. If the default gateway, if a default gateway is not defined, let me just show you that one more time. I removed the default gateway on PC0. Okay, I forgot to configure it. I go on PC0 and I say, hey, go and ping 110. Look, it will drop it straight away. Straight. What was the IP address of PC2, PC4? 254. I can even give it a stupid IP address of 192.168.50.254, which is not even a router. It is this PC. Okay? But just the fact that I've given it a default gateway, it says, oh, my job is done. I just need to send this to the default gateway. You know, I don't give a crap. I'm going to go and I'm going to send this to the default gateway. Here you go. ARP, I don't know the MAC address of my default gateway, so let me ARP it. Okay, ARP goes. Who will reply now? PC4 will reply. Okay, you can see 254 is not owned by this interface or this interface. It is belonging here. He will reply and say, hey, I am 254. What do you want? And he'll say, hey, I have an ICMP that has to go to 110. And PC4 will say, okay, I've received that packet. It is coming to my MAC address, but I am not 110, so I'll just drop it. I'm not a router, drop it. Okay, I have some questions raised here. Let me see. Yes, Suparno, all four will be received perfectly if I was to repeat that whole exercise again. One, two, 9, which is the actual default gateway. Try to ping 110. All right. The first one you can see has gone through, go into real time, and all four will go through. There are now there are no timeouts because no ARPs are being sent. Sometimes these timeouts happen because there is a ARP that has to happen. Okay, so sometimes the ARP may have to happen here. Okay, actually let's demonstrate that. Hold on. Let's do ARP minus D. I'm clearing the ARP here, and let's try the ping again. Okay, that was not nice. So it pinged straight away. So no ARP entries. Okay, it's pinging. Anyway, this is probably just a software. But the point is that the ARP would definitely go out. And sometimes it will create a request timeout, sometimes it will not. If the ARP reply comes back very quick, you may not get a request timeout. Okay, I have a question here. What if PC4 was the switch? Will it forward the packet? PC4 is a PC. It is not a switch. So can you please clarify what you mean by that question? Almaz, can you please clarify what you mean by that question?
Yeah, Professor, I'm just typing that, or should I say it orally?
Yeah, you can say it orally, because I'm just
Yeah.
surprised at the question.
Okay. So I meant that what if the PC4, I meant the IP address was of a PC4 was assigned to a switch. So it got that packet. So will it forward to the other PCs, or what will happen with the packet?
If the switch, you mean the VLAN interface on the switch was given that IP address?
Yeah.
No, the switch is not a router. Again, you have to understand that if any host machine receives a IP address, a destination IP that does not belong to that host, it will drop the packet unless that host is a router. And even the router will drop that packet if it does not have a definition in the routing table of what to do with that packet. And that's what I tried to demonstrate earlier, okay, when I showed you enable. Look at this, show IP route. Okay, this is the router. It knows what to do with 110 because 110 is connected. The IP address 110 sits inside this subnet, which is connected on gig 0/1. Okay, this interface. Now, let me go in and delete this interface. Right? Let me show you now. Okay, line protocol down means this interface has gone down on gig 0/1. Now, if I do show IP route, okay, you can see 192.168.50.0 has disappeared. It was there before, now it has disappeared. So even this router, if it receives a packet where the destination is 110, it will say, hey, I don't know what to do with this. I'm not connected to any network that may have 110, so I'm going to drop it, right? Let's see that if I do a ping, unreachable, it is going to fail. Okay, because 191.129 is saying, hey, I don't know how to reach that network. If I bring that link back up, gig 0/1, fast forward, ping again. But before I do that, I'll show you the routing table one more time. Line protocol is up. Oh God. Okay, while that is working. So let's try the ping. So you'll see some failures now because there's probably some ARPing going on. Okay, maybe, but now it's up. So those ARPs have completed, it's up. All right. So only a router is the only host device on a network that will receive a packet where the destination is not that of the router's interface. And it will say, I am a router, my job is to forward things to other networks. I will do it. A switch will drop it. Any other host on the network will drop it. That is the meaning of a router. It routes between networks. Okay, please lower your hands if you don't have a question. Rehan, Eric, I'm not seeing any questions from you guys on the chat.
Sir, I had written one.
So
Okay,
same,
let me
sir.
look.
I have
Can I just say it right now, sir?
No. That's right, Rehan. I just demonstrated that again, that the reason you saw that delay, okay, let me just show it to you one more time. I'm going to delete this interface, okay? And I'm going to show you, so the protocol is down. If I do show IP route, there is no route, okay? That interface has gone down. So all the ARP entries that were in here have been deleted. If I bring that interface back up, right? I bring that interface back up, and now I do that same ping. Okay, even though router 0 has successfully done this ping for me 3 times out of those 4, if I do it again, you will see that there'll be a request timeout. Why? Because there are no ARP entries in here for 192.168.50.110. The ARP has now successfully completed. That's when I get complete response.
Okay,
So
sir.
the ARP is very important. If there is no ARP entry, if there's no MAC address for 110, then it will ARP and wait. And in that meantime, you will get a request timeout.
Okay, sir.
Eric, I'm not seeing any question from you. Can you just paste it again? Izan, what do you mean by show the configuration of the wires on the router? What do you mean by that? Okay, I'm going to ignore that since you're not replying.
Hello, Professor.
Yes.
Yeah, that one, what you just showed to Rehan, I was asking that.
Okay. Saeed, on the router part, what exactly would you like me to repeat? So Parno, I'm dropping you off because you're not connected. Okay, you're back.
I'm here, sir.
Okay, Saeed, I'm asking you specifically. Please, everyone else stay on mute.
Yes, you said that the router is the only host device that will receive a packet. Then I couldn't hear properly what you said.
Okay, what I'm saying is that the router is the only host device that has the software that will allow it to receive a frame in which the destination IP is not that of the router, it is some other IP, and it will look at its routing table and check, can I forward this packet with this destination somewhere or not? Okay, so I'm going to use my mouse to demonstrate. When PC0 sent a frame, okay, that frame has a destination MAC of the router 0. That is what allows the frame over this Ethernet network to reach the router. But inside that frame, the packet, the IP packet, has a destination of 110. Now, router 0 is a software, routing software. This host machine has a routing software. So it will look at that destination, 192.168.50.110, and say, can I send this to any network? Is there anything connected to me that actually will have this 192.168.50.110 host? Okay, it says, yes, I actually, in my routing table, I can see that I have a network 192.168.50.0/25, okay, is connected to me, and it knows that 192.168.50.0/25 has this range, .1 to 126. So 110 is definitely sitting in this inside this network, which is connected to me, and it is connected to me over gigabit Ethernet 0/1, which is this interface here. 0/1, so it will just forward the packet out, okay? But because it did not have the MAC address for 110, it first will ARP, because now the communication between here and here is almost like just host to host. Host to host. If a host wants to reach another host, it needs to have the MAC address. Okay. So Izan, your question is, if I ping from PC2 to PC0 without putting the IP address for this, will it be successful? I am telling you over and over again, it will not be successful. Why? Because PC0 has an IP address that is not inside the network for PC2. And if that IP address is not inside the network, if the destination is not inside the network, and there is no default gateway defined, it will fail. All right, let me show you that one more time. I remove the default gateway of gig 0/1. I go in there, I try to ping. Ping 192.168.50.130. That is the IP address of PC0. Enter. It will fail. Why? Because PC2 does not have a default gateway defined. I go back into PC2. I define the default gateway 192.168.50.1. Try to ping again. It's working. Eric, please tell me if you still want me to answer that question.
So I put a question, but if you can't see it, can I just dictate it right now? It's pretty simple.
No, I can see your question. I can see your question, but I'm just wondering that I've just said exactly what you've asked. What information of the outside network should the router contain? The router should have that network in its routing table. So if PC0 wants to contact PC2, okay, if PC0 wants to contact PC2, then inside router 0, it has a routing table, which I can see with show IP route. Show IP route. And inside the routing table of router 0, it should have connectivity to the network where PC2 is sitting. PC2 is sitting inside 192.168.50.0/25, okay? And the routing table shows me, tells the router, hey, you are connected to 192.168.50.0/25. The destination is 110, which nicely sits inside 50.0/128/25, so send it. That's all the router needs. it needs to have the destination network connected in its routing table. See that C? The letter C tells you that that destination network is connected, and it is connected over gigabit 0/1, and 110 sits inside this subnet. And we already did that calculation
sir.
at the very start. All right, guys, that brings me to the end of today's class. I've spoken for almost 2 hours continuously. I hope this has been helpful. It will help you a lot with Lab 6. So please get on with Lab 6 and try to submit it within the deadline. I saw one student has already submitted it, so hopefully, I think it might, Adam, it might be you. Did you submit Lab 6? Adam, can you hear me? Or are you just choosing to ignore? Sorry, did you? I'm asking you a question.
No, Professor, it was me. I did it before the class.
Yeah. Okay. Yes, Giselle, what is the problem you have?
Actually, yesterday while submitting Lab 5, I submitted in the Lab 6 folder. And Lab 6
Okay,
only asked one submission.
there was another student that made that same mistake. Who was that?
Yeah, it's me.
All right, well, I'll make a decision on whether I'll accept it or not. Okay, if I don't accept it, I'll just give you a 0. Okay, can the rest of you please drop off, except Alam, I need to speak to you. So the rest of you can please start dropping off now.
All right.